Okay, good afternoon. This is Schweitzer. We're going to run through a little video here where we're going to be not only using the stuff we did before, mixing solutions, but we're also going to be having a chemical reaction occur while they're mixing. So first things first, we have a chemical reaction here of NaCl and silver nitrates. Let's write this reaction out if you can. At any point in this thing, make sure you're pausing the video and trying them as you go. So it's going to be, we're talking AgNO3 plus NaCl, AgCl solid plus a NaNO3. So it says here, draw a beaker to the right, and what's the minimum amount of volume needed? Well, I need at a 1-to-1 ratio here. So I need 2 silvers. I'm also going to need two chlorides. I need 2 silvers in here. And I'm going to draw the nitrates as just negatives. So what is that volume? Well, again, you can write the long way here is that I could do an ice table. But in reality, I just need the moles to be equal. They're being used at 1-to-1 ratio. So what's the moles of this guy? And that will equal the moles of that guy. So the moles of this guy is I'm using molarity equals moles per liter. Molarity times liters equals moles. You might see me start with this more often. Molarity is 0.1 times the volume of 0.01 liters equals 0.01001 moles. So I have 0.00 moles. I need 0.001 moles here too. What would be the corresponding volume with the same concentration? Molarity equals moles per liter. And I'm looking for the volume. So it's going to be liters equals moles per molarity. Moles is 0.001. Molarity is 0.01. And this gives me my answer of 10 milliliters or 0.01 liters. So would it make sense that if I have a 10 milliliters of 0.1, I also need 10 milliliters to match it if it's being used 1-to-1. Same concentration of same volume, same concentration, same volume, gives me the same number of moles. And that's something we want to keep an eye on. Minimum volume is 10 milliliters. Okay, that's the only volume. Alright, again, as we start moving through some of these, you're going to be asked to do a little more in a row. Okay, so now we're mixing up 20 milliliters and 10 milliliters, but not the same volume. So we have a proportion that's not quite as easy to do. 0.2 molar and 0.1 molar. So we have molarity times liters equals moles. So in this case, 0.20 going down to 10. So if this guy goes down by 1/2, my moles will go down by 1/2. But you notice my concentration also goes up by 1/2. So I got it backwards here. But in this case, the one went down by 1/2, the other went up by ×2, so it's a wash. We have the same number of moles. Molarity times liters equals moles. Molarity is, for the first one, 0.1 times the volume of 0.02 is 0.002 moles. Try that again with this one and you'll find you also get 0.002 moles. Draw the beaker to the right. So since I have the same number of moles, I want the same number of parts. 2 drawings here. Let's get 2 drawings for the other guy, which is this one. Ag plus nitrate. Ag plus nitrate. Alright. And there we go. Okay. I'm going to draw myself a little bit of an ice table here, just so you can see this guy. These are both limiting reactants at this point. Well, let's do this. I'll just use this other area here. And let's go. We got 0.002, 0.002 initial stoich ratio end, 0.002 0 to 0, minus 0.002. I'm going to gain 0.002. So now I need to figure out my mass of this 0.002. So 0.002, and that's going to be moles of silver chloride. Get rid of moles of silver chloride and go to grams. 1 mole, we've got to add the molar mass up. This is 107. This is 34. That's 142. And multiply across. 0.002 times 142. 0.28. So that's 0.28 grams. Okay. So you notice here that, right, determine the concentration of each. So we'll know a couple things about this you want to know. When you're doing this type of scenario, which is quite common, where do you start? Sometimes you might want to start with the spectators. The spectators, they don't do anything. They just get diluted. So dilution is, the dilution formula would be covering the spectators. All we're doing is increasing volume, no more actual content. So this is a spectator and this is a spectator. Or you can use the limiting reactant, might be one you might, because that one goes to 0. Okay, so that's for the afterwards. Let's do the beginnings quickly here. Just saying 0.1 times 1 each is just 0.1, 0.1. 0.2 times 1 is 0.2, so these are both 0.2. Afterwards, just so you know, let's do the spectators first. These guys, the spectators, both go to 0. So this one and this one both go 0 and 0. There would be nothing in the beaker. If we drew a third beaker, which we will in a moment, there would all the silvers and chlorides be gone, all on the bottom. Okay, now this sodium didn't do anything, it just got diluted. And it went from 20 to 30. So I would need to use the M1V1 equals M2V2. Or I could just use a straight up molarity form if I wanted to. Take get your moles and divide by the new volume. This guy is going to be 0.1, so I'm doing this one. 0.1, and the sodium is 0.1 is 20 milliliters. Equals unknown concentration, 30 milliliters. So 0.1 times 20 divided by 30 equals 0.0667. 0.0667. And then this guy as well, do the other one, 0.2, and it would be 10 milliliters, and then X, and then 30 would be 0.0667 as well. Alright, moving along. Alright, next one. 10 milliliters of magnesium chloride is mixed with 10 milliliters of 0.1 molar silver nitrate. So 10 milliliters, 0.1. Alright, 10 milliliters, 0.1. Appears with the same concentration. Write out a net ionic reaction and an ice table. So we have magnesium, looking at us, we're going to form solid silver chloride. So it's going to be silver plus ions plus Cl minus yields AgCl. So we're going to try and get an idea with the ice table to see who's being eliminated. Is there a limiting? Now, before I start, let's do this quickly. It's 0.1 times 1 times 2. So this is 0.1, 0.2, 0.1 and 1 each, 0.1 and 0.1. So you'll note that my chloride got doubled here. Okay. So I'm going to use moles for this guy just as I plug in my ice table. So molarity times liters equals moles. So that's 0.1 times 0.01 equals 0.001 moles. And this is for the magnesium chloride, this guy right here. So in this case my chloride, but this is for the whole thing. It doubles for the chloride. So the chloride is 2 times that. So that'd be 0.2, and that would be times 0.01 is 0.002. This guy's 0.002. This one, here we go, is just same thing, 0.1 times 0.01 equals 0.001. And these are my original moles of these guys, using the molar formula. Nothing here. You notice that 1-to-1 ratio, this is running out first, minus 0.001, and 0. So this is my limiting reactant. Go ahead right away, tag this guy is going to 0. Alright, I'm going to lose 0.001, go to 0.001, and I'll gain 0.001. So, draw it out here, draw the beaker out. Initial beaker is going to be, well, it's the same, I have the same concentration, same molarity, so I drew out 3 of these. Sorry, 1 and 2 of them, so I need 2 of these. So I'll just draw the silvers, and the nitrate will be negative. Ag plus, nitrate negative. Alright, let's draw the final beaker. 1 silver grabs 1 chloride to form AgCl. 1 silver grabs 1 chloride to form AgCl. And everything else is left behind. The nitrates are here. So the negative equals nitrate. And then I have 2 chlorides and 2 magnesiums. So the magnesiums are spectators. So the magnesium just got diluted. Now 10 and 10 is easy to do. My volume doubled, so my concentration became half of that. So 0.05. Alright, the nitrate did nothing, also goes to 0.05. The chloride, however, is a little different. Okay, now you can do this in 2 ways. You can take your chloride, this is the number of moles of chloride left. Molarity equals moles per liter. Always can fall back to this. This is 0.001 divided by the new volume, which is 20 milliliters, 0.02. And this will give you the new concentration. That new concentration is 0.001 divided by 0.02, and it's 0.05. Okay. Now, this is one where lots of times it will be in this scenario where proportions are easy to do. So let's just walk this through to get this answer with a proportion. First of all, I doubled my volume. Let's do this way. I cut half of it out. Just by dropping half of it out of solution, you dropped to 0.1. And I doubled my volume. That's going to be 0.05, which is right there. 2 halves is 0.05. All right, let's move to the next problem. Okay, so we're moving along here, and I have 20 milliliters of 0.2 molar NaOH, and is added to 20 milliliters of 0.1 molar HCl. Here's my reaction, okay, and got 2 different problems here. Give me 1 second. Okay, so let's run this problem right here. We're on the top one, and let's see what we got here. 20 milliliters and 20 milliliters, but we have different concentrations here. So you should note, because we're using a 1-to-1 ratio, that this has got 1/2 the moles, because half the concentration. This is my limiting reactant. Sometimes we also call this, I'm looking for a, well, we'll see in a moment here. I'll show you what I mean by limiting ion. Just the actual hydrogen is the limiting ion. So complete the ice table here. So I have 0.2 molars of each, so let's go here. 0.2 molar, 0.2 molar, 0.1, and 0.1. It's where I'm getting these guys from. Okay. Spectators would be the sodium as spectator and the chlorides as spectator. Those are my 2 spectators, by the way. So what is my moles of hydroxides? So molarity times liters equals moles. Molarity is 0.2. The volume is 0.02 liters. So that's my moles of my hydroxide here. So it's going to be 0.2 times 0.02 equals 0.004. So this guy is going to be 0.004. And you'll notice that because this guy is half the concentration, it should be half as much. 0.1 times 0.02, and that's going to be 0.004, 0.002, 0.002 minus 0.002 minus 0.002 plus 0.002. This goes to 0, this goes to 0.002, and of course we have 0.002 here. So I've quickly filled out the ice table. You know, note here, this is the actual item that's going away. Hydrogen going to 0. Therefore, right here, I'm going to tack this with a 0. Okay, spectator and spectator. Alright, you use your limiting reactant to figure out the mass of water. So I'm going to use, I need to figure out 0.002. So 0.002 get rid of your 1 mole equals 18 grams. And I'm assuming you can do the math on that. Alright, fill out the rest of these guys now. Now for the, I'm going to start with my spectators. I got the limiter done, so let's do spectators next. Sodium chloride. So I'm not adding any more sodium chloride. It's going to be M1V1 equals M2V2. M1 is the initial concentration. Let's do the chloride first. 0.1. And the chloride starts out with 20 milliliters. 20 milliliters and 0.1. Okay, so here we're going 20 and 20. Okay, so in this case, you'll note that my volume doubles. Okay, so of 20 milliliters, go to 40 milliliters. So X just equals 0.05. All right, 0.05. There you go. So this guy here is dropping from. They're both just going to get cut in half. So this guy here, the sodium is chlorine is 0.1. 0.2, so each of those just gets cut in half because we're doubling our volume. 0.1, 0.05. And now what about my hydroxide? Now the hydroxide, a couple things we can do here. Again, you can take just this guy here and divide it by the new volume. 0.002 divided by the new volume of 40 milliliters, 0.04. And you should get your new concentration. Okay, and that you can go ahead and calculate. Let's do it the proportional way. The 0.02, we lost half of it to 0.01, dilute it again to so it's 0.2, so 0.2 going to 0.1 and to 0.05, and that should be right here, and that should be what we get right here. Alright, so again, a different type of scenario here. Let's draw these beakers out here quickly. Same volume, half the concentration, half the stuff, same volume. I drew out here 1, 2, 3, 4. So I'm going to draw 2 of these guys. And therefore, new solution. The chlorides are still here. We're forming now H. Use a different color here. Alright. Getting close to 18 minutes, so we want to move faster. So the H and OH forms a water. H and OH forms a water. And everything else is just still here. We have all 4 of our cations. Do the cations in green. So 1, 2, 3, 4. And then we have the last thing we have is the leftover hydroxides. I'll do purple on these guys. And that's going to be 1, 2. Everything else is good to go. Alright. This guy here. Okay, we have NaOH, HCl, 50 milliliters, 0.2, and 25 milliliters of this guy. Alright, now they're the same concentration, but different volumes at this time. Okay, so at this point, who's the limiting reactant? Pause the video for a second and think about that. Okay, so I have, in this case, we have same concentration, half the volume. Now, the last time we had half the concentration, half the volume, still the same thing. So this problem is extremely similar, except that we have half the volume causing the limiting. So we're gonna do this one a little bit quicker. Let's do our concentrations here. This is going to be 0.2 and then 0.2. We have the 0.2 and the 0.2. The H plus will run to 0 because it's the limiting ion here. So this is going to be going to 0. Okay. Let's see here. Let's just run through our moles quickly here. All the same concentration here. So molarity times liters equals moles. And the molarity is 0.2 times 0.05 equals. So 0.2 times 0.05 equals 0.01. Alright, so we have 0.01. This is the NaOH, 0.01. It's this guy. Now the other guy is half that. So 0.2 times 0.025 will be 0.005, half that. 0.005 minus 0.005 minus 0.005 goes to 0. Run by limiting to 0, 0.005 half left, plus 0.005. This guy I'm assuming you can do on your own. Okay, 1 mole, 18 grams. Do that math. Alright, now, in this situation here, we're going to move along a little quicker here, getting to our end of our time limit here. How do I get I did this guy to 0 because I have nothing left. My spectators are the sodiums and the chlorines. Last time I used just a proportion. Because I don't have equal volumes here, that's going to be a little tougher. I got to use the M1V1 equals M2V2. And just they're both the same concentration, so it's going to be 0.2, but they have different volumes. This first one, let's do the chloride first. The chloride starts at 25 and goes to 75. Solve for the new volume. That's this one. The other guy starts at 50, ends at 75. I'm going to let you do that on your own. Let's do the hydroxide one. Hydroxide would be easy enough just to take this volume, this concentration, and divide by the new volume. 0.005 divided by the new volume, 0.075, and you have, I'm assuming you can do that concentration, that math. Drawing pictures, okay. Same concentration, but you have half the volume. So half the volume, same concentration. I got 1, 2, 3, 4 pictures here. So I need 2 here. H plus, Cl minus. So our picture looks identical to the last one, except for the fact that we have the volumes different. Okay. So that is where we're going to end this picture. You can look at the last one if you'd like. They're identical. And the last problem I'm going to leave for you to try on your own. It has got a very similar situation to the last question, but different chemicals. Okay, go ahead and give it a try, and we'll stop there for today. Thank you very much.